due to some technical problem, new session is created. Let us wait for 2 minutes. People are joining. Right. Topic is done, but I'm revising now. Here, the entire circuit is designed such that XL equal to XC. When the frequency is same, the pointer has to be staying at this point. If the frequency is less, XL equal to, if XL is less, means magnetization is less. So therefore, the force is produced such that the XL has to be increased. In this way, it has to move. The flux linking will be increased. As the flux linkage is increased, XL is increasing. Finally, equal to XC. Then the pointer will show this lower frequency value. That is what the actual point. Clear? Right. After that, if frequency is greater than 50, frequency is greater than 50, what is that? XL is more already, means more magnetization. If it is more magnetization, what is it here? XL will be more, means the torque is produces that XL has to be reduced. Therefore, it will be moving like this. The pointer will be showing the higher value. That is what the complete topic revised. So this is the total frequency meter. All I told you, these are different topics. That is, am I audible? Am I audible? Kindly raise your hand. Right. So this is the total discussion regarding frequency meter. In this, sir, people are saying that. Right. People are saying that, sir, what about the controlling torque? Same concept. Right. What about control? The same concept. Spring type of controlling torque is not produced, not available here. Why? In this also no initial torque. In this also no initial torque. Sir, how the opposing means? Again, the coils are designed such that the opposing force is produced automatically. No need to worry. So therefore, in this also spring control mechanism is not provided. But completely with respect to XL equal to XC only, we are going to have the operation. This is one more miscellaneous topic. Clear? All these just miscellaneous topics I'm giving. After that, one more device is there. Low power factor meter. Low power factor meter. Sir, what is this low power factor meter? See, our topic is single phase. Our topic is single phase notation only. Our topic is only single phase. Three phase means correspondingly three coils arrangement will be there. Overall concept is same only. Overall concept is same only. No need to worry. Right. That's what I told you. Sir, if frequency meet, if no supply, that's what I told you just now. If supply is removed, it will not come back to any position. That's what I told you. No spring controlling mechanism. Just now I told you half minute back. What is that? If this is shown in the previous case means that only will be shown in the next operation also. That's why just like power factor meter here also, it will show previous value only. Just like the power factor meter, it will show previous value only. In this, no controlling mechanism means no question of pointer moving back to zero at all. Same thing, just like power factor meter, same thing, because everything is indicating one of the frequency of supply is only one of the supply frequency. Therefore, yeah, there is no moving back to zero. It will stay there only. That's all these are specific meters. Few people are saying that my voice is clear. Few people are saying that voice is not clear. Kindly let me know. Am I audible? Yeah, many people are saying that audible only. Yeah, one student is giving suggestion that tell them to join computer with audio. Tell them to join with computer audio. Right, very simple. Right, what is this low power factor meter? Very simple. Yeah, here current coil will be like this, right, and potential coil will be like this, right. This is the terminal M, this is the terminal L, this is C, this is V. Okay, and here this is the supply connection. Right, sir, supply is given like this. What is that? Low power factor meter. Low power factor meter, LPF meter, otherwise strictly speaking low power factor watt meter, LPF watt meter I'm discussing. LPF watt meter, right? All I told you, in the LPF watt meter, which must be connected, L and C must be connected. So therefore, we connect like this. Normally, we connect like this. That is LC short notation. But in this LPF watt meter, some problem is there. See, everyone is saying that voice is clear. Everyone is saying that voice is clear. Check your join, otherwise check your audio setting. Those who are not able to listen my voice, check your audio setting. Right. Okay, right. Concentrate here. Sir, in the LPA watt meter, what is the logic? Very simple topic actually. Sir, TD is equal to IC IP cos phi into dm by d theta, general formula. Okay, sir, IC V phase by ZP or RPM rating by, already we have taken LP very small we have taken. No, yes. So therefore, in the EMMC, LP is very small. Leave it. So that's why I'm writing RP. Otherwise, you can ZP, no problem. Cos phi dm by d theta. So my question here is, sir, current coil is excited with IC. Right. See, here current coil is excited with the corresponding load current, that is IC equal to IL properly. Potential coil is excited with the corresponding IP notation. So therefore, my question is, sir, even though current coil and potential coils both are excited properly, due to the low power factor, because our topic itself is low power factor, means LPF load. Due to the low power factor nature, the torque produced will be not proper. It is also low only. Try to understand the terminology. Even though current coil is excited by the load current properly, means current coil is excited properly, potential coil is also excited properly. Current coil and potential coil both are excited properly. But even though these two are excited properly, due to the low power factor nature, the torque produced in the instrument is not proper, not sufficient to move the pointer properly. Even though, don't switch on your video, Gopi. Right. See here, cos phi, due to the low power factor, what is it here? Torque produced is not that much proper. That is the reason why, what we have to say now, okay, even though current coil and potential coil, according to the load values excited, phi C, phi P are proper, but due to the nature of the power factor, that is low power factor value, the torque produced is not that much perfect to have the corresponding, what is the movement of the pointer. That's why torque produced must be increased to reach the proper torque. That's why, how do we do that? Means, concentrate, I'm using some other color. In order to increase the torque, people are saying that, sir, increase the IC. Can we increase the IC? No. For a given load, IC is commonly excited. No, same thing. Can we change the V phase? No. Can we change the power factor? No. Can we change the dm by dt? No. That's why what manufacturer does, in the low power factor watt meters, while designing, simply they will reduce the resistance of the potential coil. Actually, I told you the resistance of the potential coil must be very high. I told you normally, but in the low power factor meter, to compensate this problem, what is it here? Resistance of this slightly reduced. If this is reduced, correspondingly TD will be increased. But immediately, sir, if RP is reduced, automatically, sir, through this IP will be increased. But all I told you, the voltmeter should draw the less current, means the potential coil should draw the less current. But here what is happening? Due to the reduced RP, the torque TD is, what is that? Increase, okay. But due to the reduced RP, IP also increase. If IP is increased, what happens, sir? If IP is increased, IL will be as it is, load. If IP is increased, more current will be drawn, right? Suppose earlier, concentrate here, earlier this was 9, this was 1, for example, this was 10, okay, happy, normally operating. But due to this reduction in RP, this will be increased to 1.5, for example. 9 plus 1.5, what is that happening here? 10.5 is happening. Sir, if 10.5 is happening, what is it here? Yes, this will be, load will be properly satisfied, no problem. But so this, due to this 10.5 current, the current coil gets more magnetized. Means in this entire thing, unnecessarily more magnetization is happening. Plus, second point, earlier it was 1, but due to this entire arrangement by the manufacturer, IP is increased, means in this entire potential coil, power losses will be increased. In this entire potential coil, power losses will be increased. So that's why, to compensate those power loss in the potential coil, what we have to do, that is what the complete concept. But as of now, the topic is clear, guys. Up to this, I'm coming again. Before proceeding into the conclusion, I'm coming again. What is it? Here, even though current coil and potential coil are excited properly according to the load and supply notation, due to the low power factor, whatever the torque produced is not sufficient to move the pointer properly. That's why to overcome that. What is the other thing? Here, all these we cannot change. So that's why while manufacturing, while designing, the manufacturer reduces this RP, but the two reduces to half, reduces to 30%, not like that, reduces by 10% or 15%. So as it is reduced, yes, correspondingly torque is increased, yes, sufficient torque, therefore the pointer will be moving properly, showing the value properly. Over. But my question is, sir, as the RP is reduced, current will be increased, IP will be increased. If IP is increased, automatically current through the current coil will be increased, definitely load will be same only. That's why what will be there here? Automatically the magnetization will be increased in the current coil unnecessarily, and power loss. If current is increased means I square R losses will be increased in the potential coil. So how to compensate that? That is the reason I'm writing the notes completely. Concentrate. Generally, RP is reduced, but due to this RP reduction, what happened here? IP will be increased. Due to this RP reduction, IP will be increased. That's what I'm writing here. RP reduced. It implies which one? IP increased. It implies which one here? IP square RP will be increased. That is what? Loss in the potential coil. Loss in potential coil. That power loss in the potential coil will be increased. So how do we compensate that? That's why concentrate. To compensate this. To compensate this power loss in potential coil. Power loss in potential coil. What will be there? Compensating winding. Compensating winding is used in the or in series with the potential coil. Series with the potential coil. How? Check it now. Here, this is the current coil. Like this, it is there. Right? This is load, low power factor only. This is M. This is L. Like this is there. And compensating winding is connected in series with the potential coil to reduce those losses. Here, like this, one compensating winding is connected. This will be nullifying the what is the power loss in the corresponding potential coil. But this will not be connected like this. It will be connected like this. I'm using with some other color. It will be connected like this. Connection only here. Connection is only here, but it is placed like this. Why, sir? Due to this entire thing, what is it here? Due to this increased current, I will be increased. Magnetization will be increased. No, that's why that increased magnetization is not required, unnecessary. That's why here this entire coil, this is compensating winding, is connected in what is it? Magnetic opposition with the current coil. Therefore, if this current coil increased flux is there, no, that flux will be nullified by this one, plus correspondingly coming in series. Therefore, this compensating winding will be reduces or minimizes the corresponding power loss in this. That's why the compensating winding is used, connected in which type of wattmeter? Means LPF wattmeter, not in the UPF wattmeter at all. Sir, why? In the corresponding UPF wattmeter, what will be there here? Power factor is proper, TD is proper, so automatically no question of reduction, etc., reduction is not required at all. So this is the total discussion regarding compensating. But be clear, this compensating winding is connected in series with the potential coil to reduce the power loss in the potential coil. And also we can say, yes, magnetization increased unnecessarily because load current is constant. But here increased current is, that flux will be nullified. This is what the low power factor. What all these are specific topics, miscellaneous topics. That's why I'm giving all this at the end of the chapter, at the end of the subject. Clear? Right? Any confusion? Kindly let me know. Is it clear, guys? Get it clarified. If any doubt is there, get it clarified. Right? Again, people are asking, sir, if you're keeping this coil, right, sir, here, if you are keeping this coil, right, sir, inductance is added. No, how do we but how do we nullify the inductance? All I told you, inductance effect will be nullified by the capacitance. So simply across the part of this that is common, no need to show, that is commonly present, this capacitance nullify the inductive effect, therefore normally operating for the corresponding low power factor loads. This was the complete discussion. Clear, guys? So this is the entire electrical measurement subject. That's why I told you at the end of the session, I'll be revising all the, what is it? I'll be revising, or we'll be taking the miscellaneous topics at the end of the session, I told you. Clear? Right. So this is the total electrical measurement subject for both electrical, instrumentation, and ESC also, gate electrical and ESC electrical also, total subject I have taken. And today's topic is completely miscellaneous only, but safe side I wanted to take because direct question may be possible. That's why I have taken all this. Right. Before concluding the session, if any doubts are there, you can talk to me. Right. G. Suresh, rectifier type PMMC will be there in the corresponding electronic measurements. No need to worry. And one more point I'm giving. People are eagerly waiting. Hot wire ammeter. Hot wire ammeter. This, it reads RMS value only. RMS value only. This will be there in the electronic measurements, but generally for electrical people, this topic is not specifically there, but you take it. Hardware ammeter reads RMS value. And rectified, people are waiting, rectified type PMMC, that is there in the electronic measurements. I will be taking in the electronic measurements. No need to worry. I told you only electrical measurements is done, not the complete measurements. Only electrical measurements is done, not the complete measurements. Right. Before closing the session, if any doubts are there, kindly talk to me in this entire electrical measurements. Hardwire, both AC, DC, simply any supply you give RMS value only. Ashish Kumar, I'll be meeting you in the next session, right? That will be there, no problem, no problem. For all instrumentation people together, I will complete that newly added topic. No need to worry. That is not that much depth. No need to worry. I'll give you. Extra added syllabus will be covered. No need to worry. Standardization of dynamometer. Standardization means calibration. Calibration, I told you already, in the potentiometer, in the ohm meter, I told you calibration. Same thing for every device. There is no difference at all. There is no difference at all. That's why before asking the questions, kindly go through the latest syllabus, that is GATE 2021 measurements syllabus kindly. Right? Somewhere else in the textbook, you are seeing some word and asking. That's why I told you in the AK Sahani textbook. One second. In the AK Sahani textbook, total measurement is there. Total measurement subject is there. From that, small portion is there in the gate point of view. That you need to understand. Sir, any updates for offline classes? Actually, uh, yesterday only we got one notice that in our state, especially Telangana state, especially, right, we can conduct the normal college, everything, etc. But from our office, official information yet to be received. So therefore, after that, we'll let you know, definitely. No need to worry. Ashish Kumar, current probes that will be there in the CRO, no need to worry. CRO, no need to worry. Yugasri. Sir, in series means LC is short and parallel means MC is short. Will be short, no? Come on. Yugasri, which one you're talking? In series LC, in parallel MC. Who told that? When did we take that? Come on, you're missing again. Sir, I think you missed so many classes, it seems. No need to worry, concentrate here. MC short, what is it here? UPF loads. LC short, LPF loads. Concentrate here. Here, current coil. Here, potential coil. Right? Here, current coil is always in series. Right? Potential coil is in parallel by making MC short or by making LC short. All I told you, MC, LC based on the load power factor. Based on the load power factor. Right. Is it clear, Yugasri? Kindly, I'm requesting everyone not to miss the classes. And Aishwarya. But online class is good for other state students, sir. See, don't worry. See, offline they're asking means if anyone wants to join in the offline class, they can join. Online classes will be continued. Online classes will not be terminated. Don't worry. Online classes will be continued as usual. Deep learn recorded will be there. No, that will be continued as usual. Offline will be started. If anyone wants to join offline, they can join. And a few people joined already offline, but due to this, they are shifted to online. No, yes, they will be going back to offline based on the instructions given by the management. No need to worry. Offline will not be terminated. No need to worry. Don't worry. Other state people, no need to worry at all. This will be continued. This will be continued. Yeah, that's what your question. Okay. Sir, mostly which is used means, yeah, mostly MC short only used because LPF conditions are very rare conditions. Therefore, yes, automatically UPF only we use. Aishwarya, don't worry, don't worry. Online classes will be continued as usual without any termination. Those who have taken for offline, they are asking actually. That's it. See here, so many questions will be there. Sir, online can be shifted to offline. Offline can be shifted to that will be according to the statement given at the time of starting joining. While you are joining, how did you join? On which basis you joined? Based on that, the thing will be there. Right. Mahidar paid a part. Yes, actually 9 only, but they changed it and they told that information will be given to you. Right. Manideep, from July 1st, actually, as of now, we did not receive any information from our office. After that, we'll let you know. But everyone is thinking that from July 1st, offline will be started, etc. But we need to receive the corresponding information from our office. Then only I can say. Right. Nayan Kalaskar, yes, correct. All I told you. That is only just connection point of view. Sir, in LC short, if you reduce R, then error increase. No, sir. Yeah, that's what I told you. No, yeah, that's what I told you. Who is this? 1 second. Pratyush, kindly concentrate. That's why I told you in this to nullify that, to compensate this power loss in PC. Compensating winding is used in series with PC means this compensating winding will be nullifying the power loss by reducing the current notation and all. That's why compensating. If compensating is not placed, winding is not placed, yes, power loss will be continued, but power loss will be decreased by this entire compensating winding. And So many general doubts. Sir, package of PSU jobs. PSU jobs package is around 10, 11, 12, 13, 14, 15 also package is there. Manideep, which you like, sir, online or offline? For us, everything is okay. For us, for me especially, everything is okay. For us, for everything is okay, no problem. Right. Today morning class is from 10 a.m. to 1 p.m. or 10:30 to 3. See, only instrumentation people. Only instrumentation people. I'm saying that 10 to 1, my electronic measurements class is there. 10 to 1. Electrical people, you know your schedule. And sir, online class shifted to offline after lockdown, not shifted. That is what, which coaching you have taken. While you're joining offline or online, based on that, it will be there. Yeah, Preetham, I told you 9 a.m. only for electrical people, but yesterday they informed me that 7 a.m. to 9:30 and asked them, will it be informed to electrical students? It will be informed to electrical students. They told that. Right. Sir, I'm repeating here. This compensating winding is connected in series with the potential coil and magnetic opposition with the current coil, so that magnetic flux will be opposed. Therefore, increased magnetic flux will be decreased. That's what the point. How much syllabus left for electrical? See, electrical people, electrical measurements is done. Electronic measurements is pending. Right. Sir, after completion, one second. So many doubts, concentrate, 1 second. Right. Sir, after completion syllabus, how can we contact for doubts? WhatsApp. All I told you, WhatsApp number I gave you. You can contact through WhatsApp only. Don't mail. Don't mail me. 2-3 days once I'll check the mail. That's why WhatsApp is better. Right. Right. For electrical, when will the electronic measurement will continue? It will be given to you by the corresponding schedule manager. No need to worry. It will be given by the schedule manager. No need to worry. Everything will be intimated to you. Don't worry. Right. Any more? Manish, Ali told you, sir, I'm not getting reply. How to ask your doubt? Ali told you through the WhatsApp. Through the WhatsApp, you can ask your doubts. Right. Nagasai Tota, right, correct. So in wattmeter concept, one of the wattmeter shows negative reading. Can you explain? Kindly go back and see the video because I cannot explain the total topic, right? 1 second. Do ACE conduct tests for students or only way is through test series? Definitely examinations will be conducted after completion of 1 or 2 3 subjects, etc. Intimation will be given to you. Exams will be conducted. Right. So through WhatsApp only. No, I'm not getting angry, Manish. Through WhatsApp, I'm not getting reply. See, so many people are sending one by one. I'm sending. It may be getting delayed. It will be sent. Just send that again. I'll send you. No problem. Don't do it. Maybe delayed because so many people, 500 people are there generally. So I need to reply one by one. It may be delayed. I'll send you. No need to worry. Nagasai, send that question. Right. Admin, thank you so much. Thank you so much. Very good for understanding. Thank you so much. Right. Assam, very nice, very nice. Uncertainty means relative. Uncertainty means random error only. Uncertainty means random error only. Right. So this is the total discussion regarding electrical measurements. Don't worry, electrical people, I am going to meet you again when the electronic measurement schedule is there. Mano, thank you so much. Definitely, I'll be motivating you, no problem. Again, I'll be meeting back you with respect to electronic measurements. Lot of things are there to discuss. No need to worry. Right. Extension of range of wattmeter is not there. No need to worry. Extension of range of wattmeter is not there. No need to worry. Very good. Shirish and Shivprasad, thank you so much. Electrical measurements is clear. No, that's what I told you in the last class also. See, before starting the measurements, many people told that I don't know measurements, I left it, etc., etc. But at least after my subject, did you understand or not? That is a matter. Very good. Thank you so much. Right. Maximum uncertainty means percentage limiting error. Maximum uncertainty means percentage limiting error. Uncertainty means random error. Right. Mano, thank you so much. Right. Bharat, it will be taken for 4 to 5 days, not more than that. 4 to 5 days approximately will be there. Right. Akash, very good. Thank you. Thank you so much. Very nice. Very nice. Harshavardhan, thank you so much. Yes. See, I'm very happy. You are saying that subject is clear. Okay, be very happy. But rest of the thing is pending. Rest of the thing is pending. What is that? You need to work on this. You need to work on this. That's why you need to work compulsory. Then only the subject will be more and more clear. Ji Suresh, thank you so much. Right. And people are asking this question, sir, ammeter extension is there. So this is the ammeter. This is REM. Okay. I have taken RSH. Suppose this RSH is given for which one? This is 0 to 1 ampere. This is 0 to 10 ampere, for example. I have taken this, but multiple inputs are there. Then we can take corresponding like this, simply like this. Multiple resistances, RSH1, RSH2, RSH3, RSH3, some switch will be there. Which one you want? You keep it like this. This is for 0 to 10. This is for 0 to 15. This is for 0 to 20. This is for 0 to 30. That is simply called as universal. Very simple. Nothing more than that. Bharat, thank you so much. Thank you. Thank you so much. Very nice. Very nice. Bandi Namrata, very good. Very good. This is what very nice. Right. Yugasri, thank you so much. Namrata, thank you so much. And students are saying that, sir, after practicing, I am able to increase my speed. That is what I want. That is what I want. Very nice. Very nice. Yeah. After revision only, you need to practice. After revision only, you need to practice. Thank you so much, Surya. Guru Ashish, thank you so much. Right. See, I'm going to meet you again. I'm going to meet you again. Very nice. Shivaprasad, very good. 12 pages, it is completed. No, the rest of the thing will be electronic measurements. Very nice. Very nice. Right. In the electronic measurement point of view, I'll be taking all electronic measurements again. I'll be taking all previous questions and latest paper questions also. Harshavardhan will meet you, hope in offline, Dilshuk Nagar, sir. Okay, let us hope for that. Very nice, Surya. When I practice, I got clearing doubts, sir. Yeah, that is what I require. That's why. That's why you need to go to the notes again. You need to practice all the concepts and all the questions again. If any doubt is there, go back to the recorded video at that time and get it and practice. You will get the thing. You will get the things. No need to worry. Right. So with all this, shall I close the session? Right, Ashish, yes. For us, it will be continued. It will be continued. Thank you. Vikas Wagner. Thank you. This everything is okay, but my problem here, what is, people are saying that the subject is clear. By the thinking, people are not revising this subject. Finally, they are missing the measurement questions in the exam. Don't do that. Practice this again, revise this again. Definitely you have to revise this. When we expect next class? Actually, I don't know. Your electronic measurements will be conducted in future. Right, Manivannan, thank you so much. Right. I wish you all the best, guys. Thank you so much. Instrumentation people, we are going to meet at 10 o'clock. 10 to 1, electronic measurements will continue. Electrical people, in the next schedule, electronic measurements, I will continue. Right. All the best, guys. Srinaya and Gayatri, thank you. Raghav, thank you so much. Right. Thank you.